Have you ever wondered about the water you drink every day? It plays a vital role in cooking and makes up 60 to 70% of your body. But how well do you actually understand water? Today, we will delve into its structure and properties to unlock its mysteries. Water isn't just a simple liquid, it's complex and unusual. With a chemical formula of H2O, it consists of 2 hydrogen atoms and 1 oxygen atom. Water exists in 3 states: liquid, solid ice, and gas vapor. Each state has distinct roles in food and life. Let's explore the molecular structure of water. Imagine oxygen as a larger person with 2 smaller hydrogen atoms on each side. This creates a bent shape at a 104.5-degree angle. This V-shape is critical for understanding water's unique behaviors. But what makes water special? It's polar. Oxygen pulls electrons closer, making it slightly negative, while hydrogen ends up slightly positive. This charge disparity is essential for how water interacts with other substances. It allows water to dissolve sugar and salt easily while remaining separate from oils. Next, we need to talk about hydrogen bonding. When water molecules come together, the positive hydrogen sides are attracted to the negative oxygen sides of neighboring molecules. This bond is weaker than a covalent bond but essential. It gives water its unusual properties. How many hydrogen bonds can one water molecule form? The answer is 4. This extensive network creates a 3-dimensional web, allowing all water's remarkable phenomena to occur. Now let's consider real-life examples. When you mix flour and water for bread, hydrogen bonds provide elasticity. Making jelly involves hydrogen bonds forming a delicate gel structure. Meanwhile, when you boil an egg, heat breaks hydrogen bonds, changing the protein structure from liquid to solid. Beyond bonds, let's understand water's physical properties. It has a high boiling point because a lot of energy is required to break all hydrogen bonds. This property aids in cooking, sterilizing equipment, and pasteurization. Additionally, water's high specific heat capacity ensures that temperature changes are gradual, yielding even cooking results. Speaking of food preservation, water's high heat of fusion is essential. It takes significant energy to freeze or thaw food. If we can understand these properties, we can better manage food storage and preparation. Next, we will cover why water is called the universal solvent. This means it dissolves numerous substances due to its polar nature. In contrast, oils do not dissolve in water because they are non-polar and do not form hydrogen bonds. Finally, let's touch on ice. When water freezes, it forms a unique hexagonal structure, making it less dense than liquid water. This is vital because it allows ice to float. If ice sank, aquatic ecosystems would be in jeopardy, demonstrating water's crucial role in life. In summary, water's structure and properties are key to its critical roles in food and life. Understanding this gives you insights into everyday cooking and food preservation techniques. Ready to dive deeper into the world of food chemistry? Explore more of our content and unlock nature's secrets, beginning with the fascinating journey of water.